a user-defined type similar to a class, but doesn't contain any implementation. It is simply a call or a declaration that has a signature, both in terms of the return type as well as the parameters that it accepts. So I have here a delegate that returns a type string, and I called it str delegate, and it accepts 3 different strings. That is my delegate. Now I have a method here that has the same signature, both in terms of the return type and the parameters that are also 3 strings. And that method has an implementation body. That implementation provides access to the Microsoft Visual Basic input box, where we have a prompt, a title, and a start, and an X and Y. So we're going to have in that method passing the prompt, the title, and the start, and X and Y is going to be determined by the values of the window using this. And that input box returns a string, and so we'll return XYZ as a string. But I can implement the delegate in calling that method. So then we see a button, _click event handler, in which we're going to create a delegate instance, and I named it iBox. Notice it's of type str delegate. It accesses my input dialog method. And then I can call the delegate. It's going to return a string, so I'm going to have a string variable called my name. It's going to equal the iBox, and I'm going to invoke my 3 strings. Notice there's no reference there to the input dialog method that's already been applied to the iBox. And then messagebox.show is going to return their name that they input in a welcome dialog. A delegate is simply something that stands in for something else. And here the delegate is standing in for that input dialog method. Let's watch this run. So I create a button that has this code in it. It's asking for our name. Now that's coming again here from the invoking here. Enter your name. I'll leave it at John Doe. And then I'm told, welcome, John Doe. And I get hello title. Run it one more time. I'll put in my name this time. So again, we're getting the who are you, which is the title, the enter your name prompt, and then our default John Doe. Overridden that with my name. And again, I'm told, welcome Stephen Hustedde, and the title is hello. Now, one of the strengths of a delegate is we can create multicast delegates to run sequentially. So again, I have the same delegate here, str delegate. I'm going to use that same delegate again. So in this example, I have a delegate called triangle delegate. It's going to take 2 doubles, side A and side B, and it doesn't return anything. It's a void method. I've got a method called display hypotenuse that also takes 2 doubles and returns void or nothing. And then we're going to calculate what the hypotenuse is and show a message box. We're going to display the area in the next method. Again, same signature, double double, return void. Calculate the area, display a message box there. Another method called display perimeter, same signature, double A, double B, void. By the way, the variables here can be anything you want. They don't have to be the same throughout, but as long as they're both double values, it's the same signature. It's going to recalculate the hypotenuse because we need that side C to get the perimeter, and then show a message box what the perimeter is. So then I have a button called btn multiclass click. That's this button down here. I'll demo it in a minute. We implement that same iBox delegate we saw previously to call up the Visual Basic input box, have them enter the length of side A. My default is 3.5. Length of side B, default is 4.75. Those being parsed in double values and going into A and B. So I'm using that previous delegate, and then I'm creating the multicast delegate, which I call multicast. It's of a triangle delegate. It's going to display the hypotenuse. That's the method I'm associating with it. But then we can use the plus equals compound operator to say multicast is also going to implement display area, and then it's also going to implement display perimeter, and then we invoke those 3 together using A and B. Let's give that a try. So enter the length of side A, and I'm going to do what we would normally do probably in a beginning geometry class. 3 and 4 returns a value of 5. I do 6 and 8, it should return a value of 10 for the hypotenuse. And we get hypotenuse is 10, the area is 24, and the perimeter is 24, 8 plus 6 plus 10. That's an example of a multicast delegate handling multiple methods together. We can also reassign the methods of a delegate. So in this case, I have a delegate called reassign delegate. It's referencing a double value by reference. And then I have another method called triple the amount using a double value by reference again. And then another method, same signature. This one's discount by 15%. And we're changing the value of my value, or the variable that points to as far as the argument in both cases, and changing it in the original since we're passing it by reference. And then here's my button called BTN reassigned. And that's this button down here that I'll demonstrate. But we're going to have a double value of 130.25. I'm going to create a reassigned delegate. I'm naming REDEL and assigning it triple amount. And then I'm going to invoke that by calling REDEL and passing it that value. Now this is another way of invoking the delegate. Just calling it and passing it the value. It's a little shortcut. Then I'm going to reassign REDEL. Rather than being triple the amount, we're going to reassign it as discount by 15%. I didn't use the plus equal, so it's not creating a multicast delegate. It's changing the reference of that delegate now to my discount by 15% method. I'm going to call it again using the same variable XYZ. Now XYZ is changed from the tripling. It's now $390.75 because we tripled the amount. But now we're going to discount that by 15%. We're going to show the triple amount discounted by 15% is, and I'm going to pass that value as a currency with 2 decimal, and the title will be value calculated. So let's try this. We're invoking the delegate twice, but each time with a different method that it's referencing. So I'm told the triple amount discounted by 15% is 332.14. And that seems like a reasonable answer. $390 minus 15%. The 15% would be around $58, so in some odd sense. So yes, 332.14 seems to be a correct answer. Another advantage of a delegate is we can pass it as an argument. We can't pass a method as an argument, but the delegate really is a data type container that can be passed. So in this example, I created a delegate called encryption delegate. It's going to reference a string, pass by reference a string of XYZ. And I'm creating a method called encrypt string. Again, accepting a string, in this case ABC, by reference. I'm going to take that and I'm going to reverse it, and each character I'm going to add 3 to the ASCII value. Just a very simple encryption method that's not readable. So the example I gave up here is if we pass South Mountain as that string, what we'll get is this string here, QLDW, QXR, and so forth. That'll be my new encrypted string. But then I also have a decrypt string method. Same signature. I'm going to reverse that again. This time I'm going to subtract 3 from each character, and that should put it back to its normal state of South Mountain. So I have a method here called apply change. I'm going to reference the string ABC. I'm passing it an encryption delegate with the name of ED, and then here's my button. So I have a string of campus South Mountain, encryption delegate encrypt equals encrypt string, encryption delegate decrypt equals decrypt string. I'm going to apply the change to my campus value by reference, passing it the delegate encrypt. We'll use the message box to show the value, and then I'm going to take that same reference to campus, which is my encrypted value. I'm going to pass it the decrypt delegate, so it performs that operation, and then we're going to show the decrypted form. Let's try it. So campus encrypted, campus being South Mountain, is now, and that's that QLDWQXRP#KWXRV. Notice the V is capitalized, that was our capital S. The P is capitalized, that's our capital M. And we reverse those, so the S is at the very end of the string. I'm going to click OK. And now I'm decrypting it back, and the value has returned to South Mountain. So I don't use delegates a lot, but I think it can be very, very valuable in more complex programs. Next, we'll look at a particular type of delegate called an anonymous method, and a particular anonymous method known as a lambda expression, which I do tend to use lambda expressions a fair amount. And you'll see lambda expressions used a lot as you look at other people's code. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.